This is video 2, where we will see how a farm um, finds out how much output it should produce. These are some general conditions which will apply to all market type, but the modified version of the condition may look different for different market types when we incorporate the characteristics of a particular type of a market. So we start by answering the question, what is the farm's goal? So if a farm is trying to produce an output, what goal is it achieving? What is a farm's goal? And the most common goal that is used to study the farm's output choice is profit maximization. Okay, it is not a completely unrealistic goal, although in reality, we may have managers working towards revenue maximization or any other goal, but profit maximization is the most common goal that firms try to achieve. So let us start by looking at how does a farm maximize profit? How does a farm maximize profit? So let's define profit. Profit is typically denoted by this Greek letter pi, and profit is a function of output. So pi and q in brackets it shows that profit depends on the level of output that the farm produces. By definition, profit is the farm's revenue, that is whatever the farm earns by selling its product minus the cost of producing that product. So revenue minus cost. And so in notation terms, I can write RQ minus CQ. So both revenue and cost are functions of output. So let me rewrite this. Okay. So RQ minus CQ, revenue minus cost. Revenue is price times quantity minus cost is cost per unit times quantity. Okay, P is price per unit times quantity, that is total revenue. Total cost is cost per unit times quantity. Okay, now let us try to graph or see the picture of this profit function. Okay, so this is the profit function, right? Okay, so for that means we need to look at the difference between revenue and cost. Now we already know that the total revenue function looks like an upward sloping curve. Okay, so this is revenue, okay, or total revenue, and this green curve is the total cost function, which we have derived earlier, right? So CQ are total cost, RQ are total revenue. So note that the cost function is also positively sloped, okay, but the curvature of these two functions are different. The revenue function is concave, so as you move up, the slope decreases as you move to the right. So on the horizontal axis, we measure revenue, total revenue, and total cost. And on the horizontal axis, we measure quantity. So note that as Q increases, revenue increases, but at a decreasing rate, which means if you keep drawing slopes or tangents and measure the slopes of this curve at different points, you'll see that the curve gets flatter as you move up. That means higher quantity, more revenue, but it increases at a decreasing rate. For cost, cost first decreases with every additional output. So the curve first becomes flat, then it becomes steeper. So again, by drawing the tangent. And these tangents, the slopes of this tangent, so slope of tangent to either curves is a measure of the marginal quantity. That means slope of the total revenue curve, or that this red line, is the marginal revenue curve. And as you can see, marginal revenue decreases, the slope of this red curve decreases as Q increases. So if we want to plot marginal revenue against quantity, then we know as Q increases, marginal revenue decreases. So this curve is the marginal revenue curve. Similarly, for the total cost curve, you'll see that in the relevant zone, so which is this zone, and you'll see in a little bit why this is relevant. This zone, as Q increases, marginal total cost, it increases at an increasing rate. That is, the cost curve is positively sloped. Also, the slope becomes steeper, right? The tangents become steeper as Q increases. Again, the slope of tangent is marginal, measure of marginal. So slope of tangent to the total cost is a measure of the marginal cost, which increases as output increases. Okay, now let us try to find out profit. Okay, so back to this graph. Okay, from this graph, note that what is the definition of profit? Revenue minus cost. This is revenue, green line is cost. So the difference between the two, that is any gap between these two, is profit. Okay, now note that there are two places, one is this point and one is this point, where they're equal, they intersect one another. That means total cost and total revenue are the same. If that happens, then we know that RQ minus CQ would be 0 because they are the same. That means profit is 0. So we are trying to find out how the profit function looks like. We have found 2 points where two different quantities for which profit is 0. So let's measure profits on the vertical axis, quantity on the horizontal axis. Let's call this Q1 and Q2. So at Q1 and Q2, profit is 0. Now any output less than Q1, note that cost is higher than revenue, right? If cost is higher than revenue, then this number is negative. Okay, so the profit function, the profit line would be negative if cost is higher than revenue. So for any quantity less than Q1, profit is negative. At Q1, profit is 0. Okay, now note that between these two curves, there must be some point. So now the gap starts to widen, which means profit starts becoming positive, and then it again becomes 0. So the profit function, it becomes positive. Okay, it increases, reaches a maximum, right? Because this gap is increasing. Okay, so this gap is this much here, then it becomes this much, then it again reduces. Okay, so somewhere in between, it reaches a maximum. Okay, so this is how the profit function looks like, and then it becomes 0 here, and then again negative. Okay, so our goal is to find out this quantity where profit is the highest. Let's call that Q star, because the goal of the farm is to maximize profit, right? Which happens here at Q star, where pi is maximum. Okay, so we are trying to find out the condition for this. Now, how do we find out the point or the quantity for which this gap is the maximum? Okay, so that's a simple rule. You draw the tangents, right? Two parallel tangents. The distance between them is always the highest. Okay, so parallel tangents. Parallel tangents means they have equal slopes. Okay, so equal slopes. So the slope of this tangent is marginal revenue. The slope of this tangent is marginal cost. So basically, Q star is the output for which marginal revenue is equal to marginal cost. So basically, this is that point. Okay, so this is the point where profit maximization happens, and this is where the farm wants to produce, right? So for profit maximization, okay, we need marginal revenue, which is a function of Q, to be equal to marginal cost, which is also a function of Q. Okay, and once the farm is here, the farm has reached its equilibrium. Okay, that means the farm will not change its output, and we can argue in favor of that. So if you, for instance, pick a quantity Q1. So if Q1 less than Q star, right? So note that here marginal revenue for Q1 is greater than marginal cost. So what is marginal revenue? Marginal revenue is how much the farm can add to its total revenue if it increases output by 1 unit. And marginal cost is how much the farm adds to its total cost if it increases its output by 1 unit. Now if this is bigger than this, then it makes sense for the farm to increase its output because it will add more to its revenue than to its cost. So for any point, any output below Q star, it makes sense for the farm to increase Q. Similarly, you can argue that for Q2, any output level Q2, right? Note that these Q1 and Q2 are different from these Q1 and Q2s here, okay? So these are different. For this Q2, MC is bigger than MR. MR is here, MC is here, okay? So if Q2, which is greater than Q star, there we have MR is less than MC, which means the farm would benefit from reducing output. The farm can increase its profit by reducing output. And going back here, okay, at E, when the farm is producing Q star, MR and MC are equal, which means we are here. The distance between the two lines is the maximum, so maximum profit. And therefore, the condition for profit maximization is marginal revenue should be equal to marginal cost. Now, the marginal revenue or the marginal cost can be different depending on what type of a market we are talking about. And that is how we are going to modify this condition. But the general profit maximization condition is marginal revenue should be equal to marginal cost. Now, we will look at, we will apply this condition to find out what is the output choice for a perfectly competitive farm in the short run and then in the long run in the next videos.